7 and 8. I'm going to try to get through the lesson rather quickly today, but emphasize the fact that this fractions unit is incredibly important. You're going to use this all throughout high school math, no matter what level of math you take. And you will also be using it for things like baking and fuel ratios and all kinds of things for the rest of your life. So in spite of the fact that math may not be everyone's favorite, this is a lesson to actually pay some attention to and this whole unit. So what we're looking at today is obviously we are going to be looking at adding fractions. So in order to add fractions, you need to find a common denominator. And this is stuff you've probably been doing since about grade 4 or grade 5 math. So we're going to take a look at this today with some modeling, which I know many of you don't like, but might help some of you to at least visualize what's happening. So if you look at this, we're going to start out by saying, what's the lowest common denominator between all these fractions? And people are going to start going, oh boy, this is why I didn't like fractions. In order to find that, we need to find a number or a denominator for these fractions. So the denominator being the bottom, that's the same for each one. So 3 could go into 6, but 4 can't go into 6. And so we'd have to find something, what will 3 go into, what would 4 go into, and what would 6 go into? And if we start thinking about multiples like we did before, we could look at things and go, hey, wait a minute. If I do these in 12ths, and I make this into 12ths, and I make this into 12ths, I'd have to just multiply the bottom by 4. So I multiply the top by 4 and get an equivalent fraction of 8/12. This I can multiply by 3, so I multiply the top by 3 and I get 3/12. This 6 I have to multiply by 2 to get 12, so I multiply the top by 2 and get 10/12. Right? So if we look at these, we could sort of say, we could now also even tell you which one was bigger, where it was hard to figure that out before by looking at things because the denominators were different. So if we look at things today, we are going to do some adding of fractions. And the first thing we're going to do is we're going to say, here's our question, 1/3 plus 5/6. I'm positive what I'm going to see from many of you is you're going to go 1 plus 5 is 6, 3 plus 6 is 9, and you're going to tell me the answer is 6/9. This is dead wrong. Okay, to begin with, you need to find, like we said up top, a common denominator. So fortunately or unfortunately, we are starting with some fraction strips. So if you take a look at this, we're keeping it relatively simple because you don't have the fraction strips at home to work with anyway. So we drew 1/3 as a fraction strip. So notice I've cut it into 3 pieces. I've got 5/6. I cut it also into 6 pieces because that's what the bottom said. And I colored in 5. Here I colored in 1. Then I need to find a common denominator. So notice that 3 would go into 6. So I just chopped the thirds up into 6ths. And if I look at that, my 1/3 now takes up 2/3 space. Or for those of you going, how could you get this? I could multiply this by 2 and this by 2 and I get 2/6. So now I'd look at this, and this is where some of you are going to go, but Mr. Ufer, this doesn't make much sense. I already know the answer. The answer is 2 plus 5. That's 7 pieces of 6. I know, and many of you will get to that point, but today we're asking you to try a bit of modeling. It's not that hard because you can sketch them out roughly. If you look at this now, we'd take our 2/6 pieces and our 5/6 pieces, and I'm going to take these 5 that I've got here and move this piece here, and then this piece here, and this piece here, and this piece here. And when I move all these pieces around, you'll notice that I have 1 full brick. So that's 1. And then I have 1 piece of 6 left over is 1/6. So our final answer to this question is 1 and 1/6. Or, like many of you had said before, in improper fraction terms, 7/6. We don't generally leave answers in improper fractions though. We change them to mixed numbers. Okay, so what we're going to do now is just try this real quick again. So the question this time is 1/2 plus 1/4. Again, what I'm going to see from some of you is 2/6. This answer is again dead wrong. We do not add denominators. So instead, we come here and we look at the question and we say, well, 1/2 plus 1/4. I need a common denominator. 2 will go into 4, but to make this a little bit different this time, I'm going to say, what if I didn't know 2 went into 4? One way to guaranteed get common denominators every time is to do multiplication by the 2 denominators. So 2 times 4 would give me pieces of 8. So let's say we used pieces of 8. So how did I get 4 to 8? I multiplied by 2. I multiplied the top by 2, and I get 2/8. How did I get this to 8? I multiplied 2 times 4 to get 8. So I multiply the top by 4 as well, and I get 4/8. 4/8 plus 2/8 is 6/8. Some of you are going to go, uh-oh, that's not in lowest terms. I can divide both of these by 2. So if I divide this by 2 and I divide this by 2, I'm going to end up with 3/4. Okay? So 3/4 is the correct answer. And we've done this in terms of, not using our modeling. But if we were to use our modeling, we could have done this the same way and drawn a strip that, oh boy, this is hard to do while I'm holding a phone. So here's one strip, and here is the other strip. Okay. I'm going to divide the first piece in half. I'm going to divide the next piece into 4. It said I had 1/4, so I'm shading in my 1/4, and this piece I had the 2/4. Now if I take, these are already, so this is 1 piece of 4. I need to make this maybe then, if you look at it, you're gonna go, hey, wait a minute, I can chop this here and this here, and I also have pieces of 4, but now I have 2 pieces of 4 colored in. My 2 pieces of 4 plus my 1 piece of 4 gives me 3 pieces of 4, which is the same answer we got over here. Okay. Another way to do this with modeling today is number lines. So if you looked at this, we've got 3/5 and 3/10. Need to find a common denominator again. So strangely enough, if I multiply this by 2 and this by 2, I get 6/10. 6/10 plus my 3/10 gets me 9/10. Some of you are gonna go, hey, wait a minute, we've already got the answer. I know, but if we were to use a number line, just so everybody can see it, I draw a line that starts at 0, and I get a piece that goes up to 1. Then I break it into pieces of 10. So 1, 2, 3, 4, 5, halfway, 6, 7, 8, 9, 10. All I need to do then is take my 6/10 pieces and move along the number line till I get my 6/10. And then I move up another 3. So I go 1, 2, 3. And I end up, and if I look, I'm at 9/10. So the number line is another way to model this. Okay. Then we could go and we could try this one on our own. So now we've got 1/3 and 1/4. Easiest way to do this is to multiply this by 4 and this times 3, and I'm going to get pieces of 12 for each of these. So in this case, I'm going to have 3/12. In this case, I'm going to have 4/12. Some of you again are going to go, but Mr. Rufer, I've already got the answer. It's 7/12. I know, but if we're asking you to model it, I'm going to need to break this line into pieces of 12. So I'd have 12/12, which is 1. Okay. And I'd need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then there's 12 pieces. So I would count up my first 4. So 1, 2, 3, 4. This is my 4/12 piece. Then I need to add 1, 2, 3 for 3/12, and I end up at 7/12, which is the same answer we got here. Okay. One last way to do this, although many of you will probably prefer this method for multiplication later, is to use a grid. It's very similar to the number line, except what I've done in this case, 2/7 and 1/2. I've made common denominators and gotten equivalent fractions of 4/14 and 7/14. And what I've done is I've made a grid. So this grid is in pieces of 7 down one side to match this denominator. So the 7 runs this way. And I did pieces of 2 that run this way. So then all I had to do was go, okay, well, wait a minute. I had 4 pieces. So I colored in 4. Here I had 7. So I colored in my 7. Then when I add my 4 pieces to my 7 pieces, I end up with 11 out of 14. Of course, again, many of you would have went 4 plus 7 equals 11 out of 14. I'm done. Yes, but right now we're trying to make sure you also understand what you're doing. So grade 8s, today you are doing a bunch of practice questions. Notice that it says, please check the answers in the back of your book to make sure you're doing things correctly. Show all of your work so that we know what you're doing and we can provide you with feedback if necessary. Grade 7s, you're also multiplying fractions, adding fractions today. But as you add the fractions, you're going to be dealing with shapes that we don't actually have to give you today. Normally, we'd hand you out those shapes. But if you look at it, it's quite easy to do. So here's the full shape, which is a hexagon. If I cut this in half, I end up with this shape. You could just make these and cut them out yourself to do it if you need it, or some of you will just be able to visualize it. So this thing that was a whole, I now have a half and a half. Some of you are going to go, well, how did you get the thirds? Well, if I take a look at this and I cut this like so, I now have a piece here. If I cut this like this and this like this piece is a third, this piece is a third, and this piece is another third. So there's my thirds. I could have also taken it and cut it into a whole bunch of 6. So if you look, I got 1, 2, 3, 4, 5, 6 triangles. That's pieces of 6. As you work through this today, you are going to have a few reflecting questions to answer that we will be taking a fairly close look at. So please make sure you've done those. And otherwise, have a good day, folks, and we will talk to you again soon. Bye-bye.